how steep something is defined in mathematical terms as slope. And just a couple of words. Rise is up, down. Run is right, left. Okay? Rise is up, down. Run is right, left. A couple of really quick sketches. I know the book has it in there, but I want to sketch them out and show them to you really quick. Show you my version. So let's just say this point, 1, 4. 1, 4. And here's another point, 3, 1. Let's just say I sketch out those points for you. I connect them, drawing a line. It's pretty clear to see that this particular line has a slope. It's kind of going downhill. Like if I poured a cup of water from right to left, this particular slope is going downhill.
For the chapel praise team, please go to the gym at this time.
Shoot, sorry guys. You guys know what your assignment is, right? Uphill or right, left. This is a flat line, which is said to have a slope of 0. If I make these 2 points, and this line right here is vertical, like a cliff, and vertical lines, those that are like cliffs, have no slope. Think about it this way, you can't stand on something if there is nothing to stand on, okay? So you're going to have uphill or downhill slopes like this. You're going to have flat lines like that. And you're going to have vertical lines like that. Okay? Flat lines have what is called 0 slope, whereas vertical lines have none or no slope. Okay? Now to solve for slope, numerically, it is the change in your y value over the change in your x value. Okay? Take for a second this particular sketch. If I asked you to tell me the slope of that sketch, you're going to take your y values, and it doesn't matter which one you list first. Let's do 1 minus 4. Remember, it's the change. Okay? And for the x values, since I started with the 1, I have to start with the same coordinate set. And you'll end up with -3 over 2. Therefore, your slope is a -3/2. Okay? What if you did it the other way? What if you did 4 minus 1 over 1 minus 3? Would you end up with the same slope? You sure would. Even though you might look at this and say, well, wait a minute, it's 3 over -2. It still makes it a -3/2. Bravo. Bravo. As long as whichever one you select to go first is also selected in the denominator position, the same coordinate set, you'll be correct. Either way, it's fine. And so this is very similar to what example 1 is. It's taking a pair of coordinates and finding slope. Okay? There's slope. We'll do one more just like it. Let's find the slope, pardon the frog in my throat. Let's find the slope of these points. I'm not graphing them. I'm just going to go ahead and throw them at you. Actually, I'm going to do 2 with you. Of -5, 2, and 8, 2. So it's the change in y's over the change in x. When listed like this, it's like a y minus another y, and x minus the other x. So I am just going to go from left to right. So I'm going to do the first 2 and the second 2. Yep. And that means this guy goes first. So 0 divided into 12, into 13 equal groups. Anything divided, or 0 divided into as many groups as humanly possible, the result is still going to be 0. Okay, that means 0 slope. Okay, when 0 is the numerator, it's 0 slope. Okay, so here's one normal example. Here's one that has 0 slope. 0 slope means it's a flat line, right? If you remember from the sketch up there, 0 slope means flat line. This is probably one of the main points of confusion. One more of this kind of thing. Let's see what a cliff looks like. Let's do find, yeah. Lost my place, sorry. Okay, change in y goes on the top. 4 minus 7. Change in x goes on the bottom. -3 divided into 0 groups. You cannot have 0 as a denominator. Okay, this is magic. Remember, have -3 and make it disappear. 0 in denominator means no slope. Not 0 slope, but no slope. I know that seems kind of different, but no slope, otherwise known as it is a vertical line, also known as a cliff. Okay, that's a person falling off the cliff. If 0 is in denominator, you have a vertical line. So if I were you, I would say 0 in numerator. I would write numerator, 0 slope. 0 in denominator, I would write vertical. That way you can visualize the difference between 0 and vertical. To me, when I say 0 slope, which is flat, and no slope, I get confused. It's just me, maybe it's not you. Okay. If you want to look at the theorem further, you can, but I do want to show it to you because I feel like for some of us, this is a huge light bulb. You know the formula that I just showed you guys, ax plus by equals c? Any forms, any equations in that form will graph a line. Well, if I take this and I take a divided by b's opposite, a divided by b's opposite is always going to equal the slope of the line it represents. So the coefficient of A divided by the coefficient of B, its opposite represents the slope. And they show you that here in the proof thing if you want to read that later. Remember though, if 0 is the denominator, then you have a vertical line. Okay? Let's go on to example 2. And this is where I'm going to utilize this technique. Example 2, find the slope, and I'll give you an equation. I'll give you a couple. X minus y is 2, and 2x plus 3y is 5. Question 1. Is it in ax plus by equals c form? If the answer is yes, then look for the coefficients. Okay? The coefficient here is a 1. The coefficient here is a negative 1. Okay? We now have our coefficients. 1 and negative 1. Say again?
Wait, so then what's the slope?
I'll show you here in a second.
Oh.
So, opposite of A over B, right? So A is 1, B is negative 1. So right now, it is a negative 1 over 1, right? What's the opposite of that? 1 over 1. Therefore, the slope is 1. Therefore, the slope is 1. Pretty easy, right? So A over B, this is A over B, which I just put the 1 here, or the negative here so that it floats. This is the opposite of A over B. Now the book shows you another way of doing it. You can solve for y. This is using the theorem. You can also solve for y, and I'll show you what I mean by that. X minus y equals 2. If I add y and subtract 2, I end up with y equals x minus 2. I kind of just quickly did this. And what you guys should have learned back in the day is that any equation in y equals coefficient of x plus a number, that's slope. And they're kind of just throwing that at you. We'll talk about that more. But to me, if it's in this form, use that to find slope. If it's in this form, then the coefficient of x, slope-intercept form, the coefficient of x will be your slope. And you can look at that on page 113 a little more. I'm going to do this one really quick. 2x plus 3y is 5. So 2x plus 3y equals 5. Remember, in this form, ax plus by equals c, the opposite of whatever a over b is will give you slope. So a is 2. We've already verified it's in this form. Would you agree with me?
Yeah.
The opposite, or a is 2, b is 3. The opposite, nope, the opposite.
Oh, negative 2.
Correct. The opposite of a over b is slope. So this was a over b, this is its opposite. So slope is negative 2/3. This is using the theorem. If I solve for y and find m, by subtracting 2x, negative 2x plus 5. Divide by 3. Y equals negative 2/3 x plus 5. There's slope. So, in the forms you've been given, ax plus by is c. The opposite of a over b is slope. In y equals mx plus b form, m equals slope. So depending upon what you're given, if it's given to you in this form, then just tell me what that is. If it's given to you in this form, a divided by b's opposite. Okay? That's a huge key for today. All right, I'm not done. I got one more example. Example 3. Graph a line through a particular point located at such and such with a slope of such and such. Okay, I'm going to give you the details I want. Let's see. They actually didn't give me an extra example, so I'm going to find one real quick. Okay. Point 0, 2 having a slope of 1. Okay, how do we do this? In their example, they tell you that slope is defined as rise over run. Rise is up, down, but run, we always move right when we're drawing. Okay? Rise is up if it's positive, down if it's negative, but we always move right. Run in the normal universe, like when you're looking at a ramp or roof, you might be thinking, well, it could be right or left. But in mathematical terms, using slope, run always moves right. So let's graph what I have for you. Over 0, up 2. So here's the point they've given me. 0, 2. If m is 1, that means you go up 1 for every right movement of 1. Okay, you take this and translate it into a fraction. Up 1, right 1. Up another, right another. Okay? Up, over, 1, 1. Like stairs. There's your graph. You really only need 2 points, but I only did an additional one to help you see what it looks like. There's your example. That's example 3. If it were a negative 1, 1, negative, let's just say m is negative 1, what would that look like? Then it would be, you have to apply this and make it go down 1, but always right. Okay, so if I made a second example up, say using a blue pen, down 1. Okay, I know you can't really tell too well that it's blue, but using the same 0, 2. So this is what if it's a negative, and this one here was that. watch out negatives and positives. Watch out for that stuff. I know my drawing isn't beautiful as far as the evenness of the length of the lines, but it kind of does the job.